We're going on now to topic 8 of chapter 2, solving linear inequalities now. These are not equal anymore, they're inequalities. And I have here some signs, equal signs, I think you know that one, where it's wide going from left to right. This is greater than. A point facing toward the left, coming from the left, that's less than. If you add a bar underneath it, it's greater or equal to, less than or equal to. And we're going to show you graphing techniques here as well, along with what is called interval notation and set builder notation. So these are things that will prepare you for later math classes where these are used quite extensively. But first, we want to graph that. Well, when we graph, we need a number line. And I like to make it easy by saying just put on the number line the number you're interested in, which is a -1. Now there are 4 sets of symbols for this that tie in with this down here. Let me show you them. If we have greater than, we use a bracket that faces the direction. Let me take that back here. It's a parenthesis that faces the greater. That's an error. Sorry about that. Less than would be a parenthesis facing to the left. Now, greater than or equal to, that's the bracket. Again, facing to the right. And this one is a bracket facing to the left. Okay. Clean that up just a little bit. So what do we have here? We say x is greater than or equal to -1. So we look over here, and greater or equal, we have a bracket. So at -1, we will put a bracket. Now to indicate that it's greater than that, we then darken this line and be sure we have an arrow there. So this is the graph of x is greater or equal to -1. Now, how would we show this in interval notation? We're trying to list the numbers here. Well, actually, the graph fits in very well because we just actually copy what's on the graph for interval notation. We're going to start with a bracket. That's this bracket here. And it includes a -1. So we're saying -1 is part of the set. And we put a comma, and where did we say this goes to? Positive infinity. Now infinity always ends with a parenthesis because we don't know what point it is and it doesn't have a point. So whenever you use infinity, whether it's negative infinity or positive infinity, it always ends up with a parenthesis. Now, for set builder notation, we look at this and actually we use this, but we add a brace and say x is such, and then now we just copy that. X is greater or equal to -1. So there's interval notation, there's set builder notation, and there's the graph, and there's our original inequality statement. We'll follow our same pattern as we did in previous sections. Here's example 2 on page 147. But now it's not just x, so we have to isolate the x. And again, we're going to use most of these, in fact all of them, and we're going to just make one little modification somewhere along the line that I will tell you when we get there. But we'll also graph it, use interval notation and set builder notation to build our skills. Now here, we're going to transpose the positive 4 to the other side, and that then becomes a negative 4 on this side, so that's negative 10. So how do we graph it? Again, negative 10's the number we're interested in. We look at our little chart. What symbol do we use for that? Less than or equal to. Less than or equal to is a bracket that then goes this way, and we extend that. So that's the graph. What would be our interval notation? Well, I'll put it over here. Well, it's coming from negative infinity, going up to and including a negative 10, and we put a bracket there. Now, once again, the bracket in both of these indicate that the number that we've put on the number line is included in the set. And then for set builder notation, all we have to do, once we get this, is put a line. X is such that x is less than or equal to negative 10, and this is set builder notation. So interval notation we get right from the graph, and then set builder notation from our solution. We just add the brackets, or the braces I should say, and the x and such that. Okay, this is a case where we will now introduce the one thing that's sort of different when we solve inequalities. Now, let me give you a little background. If I say 2 is, let's say 2 is less than 4, that's good. That's true. And if I multiply this by 2, both sides, I now get 4 is less than 8. And that's true. But how about if I say a negative 2 on both sides? This then becomes a negative 4 and a negative 8. Now, is a negative 4 less than negative 8? No, this is not true. So in order to keep this inequality true, whenever we multiply a side by a negative or divide by a negative, we have to reverse the direction of our inequality sign. That's super important. Put a big star by that. In order to keep this statement true, when we multiply by a negative or divide by a negative, we have to reverse the inequality sign to keep the statement true. So what are we going to do here to solve for x? We're going to divide by a negative 2. Now this will become an x, but in order to keep this true, we have to reverse that. That will now become, oh, I didn't reverse it, greater than or equal to 2. When we divide by a negative or multiply by a negative, in order to keep the inequality true, we have to reverse the direction of our inequality sign. This is the proof of it here. Now let's wind it up by saying, what's the graph of this? Well, there's a 2. We want a greater than or equal to. We're going to use a bracket facing this way. Convert this now to interval notation. It will be a bracket at 2, comma, parenthesis around your infinity. And then set builder notation, all we do is we put a bar here, an X, and braces. So we solved it. We had this technique of when we divide or multiply by a negative, we have to change the direction of the inequality sign. We made the graph, we got our interval notation, and there's our set builder notation. I think we can do 2 examples. So here's example 4. To solve it, we're just going to divide by 2. And we get x is less than -2. All right, we'll graph that in a moment. Let's do this one. Now notice here we have a -4x. If we kept it this way, we'd have to reverse the sign. But a way that might be useful, if you want to use it, is take this, bring it over to this side, let's transpose it, it becomes a positive 4x on that side. Bring the -9 over to this side, that becomes a positive 9, and this will become 16. So when we divide this by 4, we get x, and then reading it this way, is less than or equal to 4. Now, that's okay, but for some people, if it bothers you, you can just change it. X is less than, remember the point is toward the x, 4. There's the standard way. And now let's graph it. The number we're interested in is -2. Now notice this is a sign we haven't used the symbol for yet. It's less than. So less than is a parenthesis facing to the left. And to put that in set builder notation, and interval notation is coming from -infinity, goes up to -2, but -2 is not included in the set. That's why we have a parenthesis there. It goes up to it, but it's not included. And then for this one, interval set builder notation. And to graph it, we're graphing the 4, and this would be a bracket this way, going this way, and this would be from -infinity up to 4, but 4 is included in the set. All right, examples 4 and 5. Again, you can look at the textbook. They give you a lot more detail. All right, we're going on to example 6. So here we're going to use, there's no fractions, there's no grouping symbols, there's no collecting like terms, but we need to transpose, so we isolate the x's. So if I move the x over to this side, this just becomes x. I move the 7 over to this side, this now becomes a -7, and this will then become a -18. And we have to use the correct sign. There we go. So to do our graph, the number we're interested in is -18. This is less than or equal to, we're going to use this sign, where we have it move the other direction. And our set builder notation and interval notation, it's coming from negative infinity going up to negative 18, and the bracket indicates it's included in the set. Remember, we use a bracket when it's also equal. All right, these are just a couple more examples. Notice this is a negative 5x, but we need to clear parentheses now, our grouping symbols. So negative 5x plus 7 is less than 2x minus 6. Again, a good technique is to keep the x's positive. Thereby, you won't have to change inequality signs, their direction. So I'm going to add 7x to both sides. I'm sorry, 5x to make this 7x. Subtract, well, add a 6. This makes this 13. Divide by 7. And then I'm going to rewrite it so that it's x is greater than 13 sevenths. Again, in set builder notation, we would just put an x there, braces. For the graph of this, our number is 13 sevenths, and our sign will be a parenthesis facing toward the right. So interval notation will be parenthesis 13 sevenths, comma, positive infinity. In number 8, it's just a little bit more. We'll clear parentheses first. We'll group like terms. And again, I want to keep my x's positive if I can. So I'll transpose this, and I'll bring this over, and I'll rewrite it. And then set builder notation. And our graph, I think we did this one already here. We're going to use a brace, a bracket I should say. Interval notation. And that should wrap it up. Okay, here we're dealing with what is called compound inequalities, where you have the value of x in the middle of two inequality signs. So this one, all they're asking us to do is to graph it and, so let's make a line. The numbers we're interested in are a 4 and a 2. Our x is in the middle, so what do we put here? Well, we're going to put a parenthesis here because 2 is not included in the set. And what do we put here? Well, a bracket, because 4 is included. So we fill in our x range. And then for set builder notation, all we would do is what we've been doing. And for interval notation now, here it's starting at a 2, but 2's not included, and it goes up to 4, and 4 is included, and that's interval notation. Okay, now what we're getting into is actually solving a compound inequality, because we don't have x by itself. So there's a technique, and the technique is to isolate the x. So whatever number with it, we will add 3 there, add 3 there, and add 3 there. This takes us down to our next step, which will be 2 is less than or equal to 2x is less than 8. So again, the technique for getting rid of a number that's in the middle there is to just use its additive inverse. Transposing doesn't work too well here because of the x, and there's like 3 parts to it. And now, though solving is the same, we're going to divide this by 2, divide this by 2, divide this by 2. We then get 1 is less than or equal to x is less than 4. So when we graph it, our numbers are 1 and 4. And then here we're going to have a bracket. Here we're going to have a parenthesis. We're going to fill it in. This is our set builder notation. And our interval notation is bracket 1, comma 4, parenthesis. Now I don't know if you've noticed that building interval notation from the graph is really the best way to go, because these two relate. And we're going to wind up the chapter here shortly. As we do example 11, here we see there are fractions. So we've dealt with grouping symbols and some of these others. But now let's just review dealing with fractions. Now the rule here is pretty much the same. Whatever your lowest common denominator, you're going to multiply every term by that. So that takes care of the fractions. Now you're making an inequality that's not quite the same, but it's equivalent, and the x still is worth the same. So you multiply through. This will be 6 is less than or equal to 3x plus 8 is less than or equal to 10. Now your next step is to isolate the x again. So I'll use this technique. Notice we're doing the same thing to each part of our inequality. So this then gives you negative 2 is less than 3x is less than or equal to 2. And now, no fractions, nice. I'm going to divide this by 3, this by 3, this by 3. 3's cancel out, and we get then negative 2/3 is less than or equal to x is less than or equal to 2/3. In set builder notation, and then to graph it, we're going to have a negative 2/3 there, a positive 2/3 there. We're going to have a brace this way, or I should say a bracket this way. And we fill it in. And then interval notation, bracket, negative 2/3, and then 2/3 bracket. Example 11. We have 2 more before we complete the chapter. And we have to have a few word problems. For example, 12. 12 subtracted from 3 times a number is less than 21. Find all values that would meet this. Well, setting it up, 3 times the number we said could be 3x. Now from that we're going to subtract a 12, and that's going to be less than, only the less than, 21. So we're going to transpose that, and this will be 33. And we're going to divide by 3. X is less than 11. So, set builder notation, graphing, X is less, parenthesis, darken arrow, and then interval notation now from negative infinity up to 11, but 11 is not included. Okay. For our last example, here someone's planning a wedding, and they're going to spend up to $2,000 on their budget for the wedding. Now the hall that they've rented have a setup fee of $100, and they will charge $35 per person to participate. So how many guests can this couple have at their wedding? Well, we know they want to spend less than or equal to 2,000. We have a setup fee of 100, plus it's $35 per guest. So that's your basic inequality. Now how do you solve it? Well, we're going to transpose this. And this becomes 1,900. And then we just divide it by 35. NG is less than or equal to, and I'll use my trusty calculator again, 1,900 divided by 35, and I get 54.28, and it trails on. The answer being, I could have, as your interpretation, 54 guests. And I don't know if that includes the bride and groom or not. Well, okay. Hopefully you're on task, you're up to date, you're doing your reading of the textbook, the practicing, the quiz maze, and you're going to be ready for your test. And good luck.